In this section, we're going to talk about different types of triangles. And then we'll even prove that a given triangle is of one of these special types. The first type is a scalene. Scalene triangle. No sides are equal. No two sides are equal to one another. That is, they're all different sizes. Then you have the famous isosceles triangle. Isosceles triangle. Two or more sides are equal. So, for example, you might have a triangle like such. 2, 5 inches, and 5 inches. That is an isosceles triangle. You can have 8, 8, and then 14. Since the 8 and the 8 are the same, it is an isosceles triangle. If you can find two sides that are equal to one another, you have an isosceles triangle. And on this triangle, I could find two sides that are equal. This side and that side, or that side and this side. And if two or more sides are equal, it is an isosceles triangle. But we'll give our strongest statement if all three are equal. We will call it an equilateral triangle. Equilateral triangle. All three sides are equal to one another. So, the last triangle I drew, that is an equilateral triangle. You can also call it isosceles, but a stronger statement would be equilateral. Lots and lots and lots of students and teachers, unfortunately, if you give them this triangle and you ask them, is it isosceles? They will say no, it's equilateral. Well, that's not correct. It is an isosceles triangle. You can say a stronger statement. You can say that it is equilateral, because all three sides are equal. Okay, so scalene is when no two sides are equal. Isosceles is when two or more sides are equal. Equilateral is only when all three sides are equal. Now, I want to go back and change one word. Instead of sides, you can have angle. In this last triangle, the one to the right, all three angles are equal. If all three angles are equal, and since the three angles add up to 180, they must all be 60. They can't be 40, because 40, 40, and 40 is only 120. If all three angles are equal, then it is an equilateral triangle. And since two or more angles are equal, it is also an isosceles triangle. If two sides are equal, their opposite angles are equal. This angle and this angle are equal. That makes it an isosceles triangle. Opposite 5 and opposite 5 are those two angles. Since two angles are equal, it is an isosceles triangle. It is not an equilateral triangle because the third angle is not equal. Opposite the shortest side, namely right here, that's going to be the shortest angle. Opposite the longest side will be the biggest angle. Opposite two sides that are equal will be equal angles. Now, do want to give two more definitions. An acute triangle. All angles are less than 90 degrees. Acute triangle. Now you have an obtuse triangle. One angle is more than 90 degrees. Well, is it possible that you can have two angles more than 90? Okay, whether this picture looks like it or not, let's suppose two angles is more than 90. Let 90 plus mean more than 90. And this be 90 plus. And this one, I don't really care about. Well, you know what? When you add the two angles that are more than 90, you're going to get more than 180. And then when you add the question mark, it'll even be more than 180. Okay, so no, you can't have two angles more than 90. In fact, you can't have two angles that are 90. Because if this triangle somehow had two angles that were exactly 90, and the third one we don't know about, well, when you just add two of them, you get 180. And when you add that third unknown angle, you're going to get more than 180. And the three angles must add up to 180. The next definition is going to be a right triangle. A right triangle. It has one right angle. That is a 90-degree angle. It has one 90-degree angle. Here is a right triangle. This angle right here is 90 degrees. Alright, so we'll do some proofs at this point. They'll all be pretty much elementary. Suppose you have the following triangle, or following diagram. Let me get rid of that, please. And you're asked to prove that triangle ABC is obtuse. Let's call that point D. Well, first, the concept or the logic is going to be that's 180 degrees, that big angle. And if this part is 60, well, then the other part must be 120. And so triangle ABC has a 120-degree angle, making it obtuse. Okay, but we don't know that it's 120. All we're giving is the 60. All we're giving is that 60-degree angle. So, the statements and their corresponding reasons. So we're given that angle BCD, the measure of angle BCD is 60 degrees, and that's going to be given. And then we're going to say that we have a straight angle. Angle ACD is straight. And I guess I'll say by construction. It's given. So angle ACD, the measure of angle ACD is 180 degrees. In statement 2, I meant to say the angle is a straight angle. All straight angles equal 180 degrees. Statement 4, the measure of angle, this angle right here, ACD, is 120. And that's from subtraction property. From 180, I took away 60. I ran out of room, so statement and reasons, and here we're done. Triangle ABC is an obtuse, should have said obtuse triangle, is an obtuse triangle. This is statement number 5. The reason is by definition. Any triangle that has an angle greater than 90 degrees is an obtuse triangle. And there's my proof. Although we need to be exact in these statements. I'm going to call that number 6. And statement number 5 is going to be angle ACD is an obtuse angle. And then it's probably cleaner to say it this way. And it says that any angle greater than 90 degrees is obtuse. Any triangle that has an, I'd rather not use this. Any triangle that has an obtuse triangle, obtuse angle, is an obtuse triangle. Any triangle that has an obtuse angle is in fact an obtuse triangle. Okay, so that's what I want to say. And that's proof. Sometimes they're messy to write off, and if you're taking a geometry course, you grade it on how you write up the proof. But that's secondary. Very important, but nonetheless secondary. The main thing is to see the logic. suppose we have a triangle like this. E, F, G, and point H. And you are given the following. You are given that EG is equal to FH, the length of EG. I like the way I write my G's. The length of line segment EG is equal to FH, and the length of line segment EF is more than the line segment of EG. And you want to prove that triangle EFG is scalene, which means you want to show that all three sides are different lengths. Statement, reasons. 1, that. Reason, it's given. Now, they tell you that EG is equal to FH. That is this length right here. No way, that one doesn't like to work. Okay, oh well. You are given that length and this length are equal. Well, that means FG is smaller than EG. We know that FG is smaller than GH. It's part. FG is part of, oops, I meant to say FH, the whole line. FH and FG is smaller. This piece is smaller than the whole thing. A part of a line segment is smaller than the entire line segment. Okay. So now what we can say is that FG is smaller than EG. Okay, because remember, this part here is equal to FG. FH. So that means that FG is smaller. And basically, what did we do here? Well, remember, in one of the givens, we have this. We have that FH is EG. Well, all I did was replace FH with EG. You may replace equals with equals. You may replace something with its equal. Okay, so now we have that EG, well, let's call this 1. We have that side 1 is smaller than side 2. Okay, but in turn, now remember, so far, EG is the bigger one. But EF is even bigger. EF is bigger. EF is now bigger. Triangle EFG is scalene. All three sides are of different lengths. Okay, that's that one. Try one more. Here's a nice problem. Suppose this is 10 and this is 2x plus 5 and this is 3x minus 2. And the perimeter is, say, 63. Okay, instructions are to prove that triangle ABC is scalene. How if you add up all the angles? 2x plus 5, 3x minus 2, and just positive 10. On one hand, you get 5x plus 13. 10 plus 5 is 15. Minus 2 is 13. And 2x plus 3x's, when you add them, are 5x's. On one hand, you get that. On the other hand, get 180. No, that's absurd. On the other hand, you get 63. We're not adding up the angles. You get 63. Well, you should know that 50 plus 13 is 63. 5x must be 50. And if you were to take away 13 from both sides, you can get that as well. 5x is 50. Well, if 5x's are 50, know your times table, 5 times 10 is 50. So x is 10. 2 times 10 is 20, plus 5 more is 25. 3 times 10 is 30. Take away 2 is 28. So one side is 10, the other side is 25, the third side is 28. You have a scalene triangle. All three sides are of different lengths. Okay, that completes this section.